Building reliable AI agents start with one question. Should this task be handled by one agent, many agents, or a human-reviewed workflow? In this video, we will quickly go through 4 proven AI agent design patterns in Flowise, showing you how each one helps you structure agentic systems that are faster to build, easier to maintain, and better suited for real-world use. If you are building on Flowise, all of the agent design patterns in this video can easily and quickly be used for free with one click on the Flowise Marketplace tab. The simplest agent pattern is a single agent with access to tools. A common example is RAG, Retrieval Augmented Generation. One agent uses a retrieval tool to pull relevant information and give a more grounded response. The biggest strength of this pattern is simplicity. It's easy to build, easy to understand, and works well when a single agent can handle the task with help from one or more tools. Its main limitation is that one agent still has to do all of the reasoning. As workflows become more complex and the context gets larger, the agents become less accurate and more likely to hallucinate. When one agent is not enough, it often makes sense to split the work across multiple specialized agents. You could create a more deterministic workflow by understanding AI agent design patterns. One agent is able to have all of these capabilities, but having the steps makes it more likely each agent and step triggers. In a sequential pattern, the output of one agent becomes the input for the next. The workflow follows a fixed step-by-step order. For example, in this team-building agent, the first agent analyzes project requirements, the second identifies the roles and skills needed, the third matches those needs with candidate profiles. If you have used AI, you're probably aware that there's a chance that an agent misses one of these steps. But when you create a workflow like this, it guarantees these 3 steps happen even if an individual step fails in between. Because each step happens in order, the process is structured and easier to control. Each agent has a focused responsibility, which also makes the system easier to debug. The main advantage of sequential workflows is predictability. When you need a repeatable process with clearly defined stages, this pattern works well. Not every task needs to happen in sequence. Some steps can run independently and all at the same time. That is where parallel agents are useful. Using the same team building example, once the project requirements are clear, you might launch several agents at the same time. One evaluates your needs and designs the team, one searches for engineering candidates, one assesses project management fit, and a final agent can combine the results and recommend a team structure. The biggest advantage of parallel design is speed. If tasks are independent, running them concurrently can reduce latency. Trade-off is coordination. Parallel systems often need an aggregation step, something to bring all of the stuff together. And combining outputs from multiple agents adds complexity. Too many requests may also cause throttling or rate limiting, depending on how many things you're doing in each step. One of the most important patterns in real-world AI systems is human in the loop. This matters when stakes are higher and you do not want the system acting fully autonomously. This pattern combines the speed of AI with human judgment and accountability, and the main benefit is trust. A good example is an email agent. The agent can draft a message, but before anything is sent, a human reviews it, edits it if needed, and approves the email to be sent. In Flowise, we're able to control where we get inputs using the human input node. On top of manual checkpoints, agent can also be configured to request permission before executing tools, similar to how Claude asks for user approval before using MCP tools. Check out this tutorial on Human in the Loop if you would like to see a step-by-step implementation of this pattern. Each pattern solves a different kind of problem. Single agent with the tool works well when one agent can handle the task and just needs access to outside information or capabilities. Sequential agents are best when the workflow needs structure, order, and dependable handoffs. Parallel agents make sense when subtasks can run independently and speed matters. Human in the loop is the right choice when accuracy, judgment, and accountability are critical. In practice, the best systems often combine these patterns. For example, you can use a single agent with a retrieval tool to gather context, run multiple evaluators in parallel, and require human approval before taking action. And then you can send the results to more agents if you like. In the next videos in this series, we will go more in depth and build an example use case for each AI agent design pattern in Flowise. By the end, we will build custom multi-agent systems and advanced AI agent design patterns to take your AI workflows to the next level. Thanks for watching, and we'll see you in the next video.